So in question 2, this question is on vectors. The diagram shows two vectors x and y, and the vectors are shown here. This is vector x, this is vector y. In which vector triangle does the vector z show the magnitude and direction of vectors x minus y? So we are told that z is equal to x minus y. At this point, we remember that x minus y is the same as x plus minus y, because in most cases we deal with addition of vectors rather than subtraction of vectors. So we can treat subtraction of vectors as a special case of addition. We are just adding negative vector or negative y. So if vector y is in this direction, minus y is in the opposite direction. So this is minus y. So the vectors that we are dealing with is vector x and vector minus y. These are the vectors that we are adding. Remember, we are doing addition. So when we add vectors, we usually connect them head to tail. So we start with the first vector here, and then we slide this until its tail makes contact with the head over here. And then finally, we come to where we started from to where we stopped. For instance, here, I've drawn the same vectors. Over here, I have the same vectors. This is vector x and this is vector y. So we are going to slide this vector until its tail makes contact with the head of this vector, like this. So we slide it from that point to that point. Notice that vector minus y is pointing in the opposite direction to the direction y is pointing. And therefore we are going to draw a line from this point, that is from the first tail to the last head, like this. So this becomes vector z. This where we started, this where we stopped. But in our choice here, you'll find that there is no vector which points in this direction. So we've got to obey the rules here. So here we can say this is vector z. Of course, this is x and this is minus y. Remember, they are the two vectors that we were adding. And we're using a very simple rule that when we add vectors, we usually connect them head to tail. The vectors we are adding is vector x and vector minus y. So z is equal to x minus y, which we have translated to mean x plus minus y. So we are adding vector with negative sign. So the rule is addition of vectors. When we add vectors, we connect them head to tail. So we identify the tail of the first vector here and its head. And therefore, we arrange them in such a way that the head of this first vector is connected to the tail of the second vector. And then finally, we draw a line from the first tail to the last head, because this way we have the last head. This will represent z, which is x plus minus y. But in our choices, there is no vector which points in this direction. Y still points in the same direction. So we can still end up calling this or changing the direction of minus y to point to the right, and therefore it just becomes y instead of minus y. And that is exactly what we have done here. This is what we have done here, in the sense that vector y still points in the same direction, x points in the same direction, and this is z, which is x plus minus y or minus y. So this will represent the vector x minus y. So let's look among the choices and see which one represents that. And you can see that the correct answer is B. To sum up this point, it is very simple. Z is equal to X minus Y. In vectors, we usually deal with addition of vectors to get resultant vector, and we rarely talk about subtraction of vectors. So we convert subtraction of vectors to a special case of addition. So we are adding, I have vector X, I'm adding minus Y. This is like saying these are the vectors that we have. X has got its original direction plus the vector we are subtracting or we are adding is this one here. The change in direction here represents the negative sign. So since these are the two vectors that we are adding, we arrange them head to tail. That one and that one. And therefore we realize that the resultant is this one here. This is Z, which represents X minus Y.